All right, let's just jump right in. We're going to go on a quick tour of all of basic math, starting from the absolute ground floor. The goal here isn't to get bogged down in a bunch of complicated problems, but to really see how every single piece connects, how it all fits together into one beautiful logical system. And this right here, this is the core of the problem, isn't it? So many of us feel like math is this impossible mountain we have to climb. But what if I told you it's not? The issue is we usually learn it in these little isolated chunks, and we never get to see the whole map. Well, that's what this is. This is the map.
So where do we even begin? Well, we have to start with the absolute fundamentals. Think of these as the atoms of the math world, the basic building blocks that everything, and I mean everything else, is built on top of.
Now, this might seem super simple, but it is one of the most powerful ideas in all of mathematics. It's called place value, and it's what gives our numbers meaning. You see, a 2 isn't just a 2. In the number 251, that 2 means 2 times hundreds. But if you move it to the end, it just means 2 ones. Its position changes everything. This is the system that allows us to write any number you can possibly imagine. Okay, so once we have numbers, we need to actually do stuff with them. And believe it or not, there are only 4 fundamental things you can do in math. Just 4. Add, subtract, multiply, and divide. That's the whole shebang. Every complex equation you have ever seen in your life is just some combination of these 4 simple moves. All right, so we've got our building blocks. Now we need the instruction manual. We need the rules of the game that let us use these blocks in a way that's consistent and makes sense. This is where we go from just having numbers to actually doing mathematics. Sometimes we need to talk about parts of things, right? Not just whole numbers. And this is one way we do it, with a fraction. Just think of it as one slice of a pizza that's been cut into 2 pieces. Simple enough? But we can also talk about that same idea using a completely different language. And that's what a decimal is. It represents the exact same amount as 1/2, it just looks different. It's another format for saying the same thing. And here's the third way, a percentage. You see these all the time. It literally just means per 100. So 50 out of 100 is, you guessed it, the exact same value. The big takeaway here is that fractions, decimals, and percentages aren't different concepts. They're just different ways of saying the same thing. Now, what happens when you have a problem that has adding and multiplying in it? Which one do you do first? To avoid total chaos, where everyone gets a different answer, math has a universal rulebook. You've probably heard of it, PEMDAS. This just makes sure that no matter who you are or where you are in the world, you follow the same steps and get the same answer. It's like the grammar of math. Now, let's talk about a really useful shortcut. Instead of writing 2 times 2 times 2, we can just write 2 to the power of 3. That's an exponent. It's just a shorthand for repeated multiplication. And then roots are just the opposite. They ask the question backwards. What number times itself gives me this number? They're a perfect inverse pair, like yin and yang. Okay, this is the part where a lot of people think math gets scary. But I promise you, this is actually where it gets incredibly powerful. This is where math stops being about just following rules and turns into a tool for discovery, for solving puzzles. Exactly. I mean, think about it. So far, we've been working with numbers that we already know. But in the real world, we're usually trying to find a number we don't know. The price of something, the distance to a destination, a certain amount of time. So how do you deal with that? We use algebra. And don't let that word intimidate you. All algebra is using a placeholder, usually a letter like X, to stand in for that number we're looking for. It's not some new, terrifying kind of math. It's just a technique for finding missing information. It's detective work. And the core principle of algebra is this. Think of an equation like a balanced scale. To figure out what X is, all you have to do is keep the scale balanced. If we take 3 away from the left side, we have to take 3 away from the right side to keep it from tipping over. And just like that, the puzzle is solved. X equals 4. It's all about balance. Okay, so we've got the building blocks, we've got the rules, and we have a way to find the missing pieces. Now for the big question. Why does any of this matter? Where do we actually see all these concepts at work in our daily lives? You use ratios and proportions all the time, probably without even realizing it. When you double a recipe for dinner, that's a proportion. When you look at a map, the scale is a ratio. They are the tools we use every day to compare things and to scale ideas up or down, whether we're in the kitchen or on a construction site. And then, of course, there's geometry. That's just the math of the physical world. It's how we measure the space we all live in. The perimeter tells you how much fence you need for your yard, and the area tells you how much carpet to buy for your living room. Geometry is the math that lets us design, measure, and build the world around us.
In today's world, we are just flooded with information, with data. So how do we make any sense of it? Well, one of the simplest, most powerful tools we have is the average. It can take a whole messy group of numbers and give you back one single number that represents a typical value. It cuts through the noise for us.
And that brings us to the grand finale, the one big idea that ties everything we've talked about together. All of it, from place value to algebra to geometry, is really just the study of patterns. That's it. Math is the language we invented to describe patterns, predict them, and use them to solve problems.
So please remember that math isn't just some long list of rules you have to memorize. It's a tool. It's a lens for understanding the world. It's not about being a math person. It's about learning to see the underlying patterns that are all around you. So the only real question left is, what are you going to use it for?